Alright, let's take a look at this following system of linear equations, and let's use Gaussian elimination and back substitution to solve for the solution set. Now, we're going to be converting this system of linear equations into an equivalent system of linear equations in row-echelon form, and we can do that using our elementary row operations here. Remember, we can interchange rows, we can multiply a row by a non-zero constant, and we can add a multiple of one row to another row to get a new row. Now, I am referring to the row terminology to refer to each equation. So when I say row 1, what I mean is equation 1. Row 2 would be equation 2, and row 3 would be equation 3. For me, it's just easier to say row instead of equation, and you'll know why once we get into the topic of matrices. So, generally when I tackle these types of problems, I like to start at the top row, first column. So it would be this column right here. And what I try to do is I try to get a leading one term for the first term, and then I try to get these to be zeros. And then I kind of work myself to the second column, and I try to get these to be zeros, and then finally the third column, I try to get my leading one z term here. So the first thing I'm going to do is I'm actually going to multiply row 1 by a non-zero constant, and that's going to be negative 1/3. Right? And that's going to give us our new row 1. So let's see what happens when we do that. So the first equation is negative 3x plus 6y plus 3z is equal to 18. And if I multiply this whole equation or row by negative 1/3, well, this first term, negative 3 times negative 1/3 is just x, right? And then the second, 6y times negative 1/3 is minus 2y, and this third term, 3z times negative 1/3 would be minus z is equal to, well, 18/3 is 6, that'd be a negative 6, right? So this right here is our new equation 1, and look at this, we got a leading one term here, right? So if I write our new equivalent system with the new equation 1 or row 1, we would have x minus 2y minus z is equal to negative 6, right? This just came from here. And then we have negative 2x minus 2y plus 10z is equal to 16. That's just the second equation here. And then we have 4x plus y plus 5z is equal to 12. And that's just this third equation right there. Right, so now we have our new system of linear equations, an equivalent system. And so the next thing I'm going to try to do is I'm going to try to look at this term, and I'm going to try to get that to be a 0 times x term, right? We're trying to make all the terms below each leading one term a 0. So I'm actually going to look at my third rule here, which says I can multiply one equation by some constant c, and I can add it to another equation to get this new equation. So let's take a look at this second equation. We have a negative 2x term here. If we had a positive 2x term somewhere, we could add those two equations together and this would cancel out, right? 2x minus 2x is 0. So what if I multiplied this first equation by 2 and then I added it to the second equation? So what I'm saying is, if I scroll down, what if I took the second equation, R2, and I added 2 times row 1 to get the new R2? So equation 2, which is this equation right here, is negative 2x minus 2y plus 10z is equal to 16, right? And then I took 2 times equation 1 and I added it to this equation, right? So what I'm saying is, let's multiply equation 1 by 2 and I'll get 2x minus 4y minus 2z is equal to negative 12, right? So let's add these two equations together, and in the first column, the x column, negative 2x plus 2x is just 0, right? And then negative 2y plus negative 4y is negative 6y. 10z minus 2z is positive 8z. And then finally, 16 minus 12 is just 4. So now this becomes our new R2, right? We take 2 times R1 and we added it to R2 to get our new R2. So now if I scroll down a little bit more, we have another equivalent system, which is x minus 2y minus z is equal to negative 6. And then our new equation R2, which is this, is negative 6y plus 8z is equal to 4. And then finally our third equation was 4x plus y plus 5z is equal to 12. So great, we got a zero term here. And now what I'm going to do is I'm going to try to get rid of this term right here and make that a 0. So I'm going to use that third rule again, and I'm going to say, I'm going to take R3, equation 3, which is this equation right here, and I'm going to add to it negative 4 times equation 1, right? So if I multiply equation 1 times negative 4, I'm going to get a negative 4x here. And then if I add it to the third equation, I'll get a 0 in the x term, right? So this is going to yield our new R3. So let's do that. R3 was 4x plus y plus 5z is equal to 12. And then negative 4 times this equation is going to give us negative 4x plus 8y, right? Negative 4 times negative 2y. And then plus 4z here is equal to 24, right? Negative 6 times negative 4. And then let's add these two equations together. The first column, we're going to get 0. And then 8y plus y, we're going to get 9y. And then 5z plus 4z, we're also going to get 9 times z. And that's going to be equal to, well, 12 plus 24 is 36, right? So this is our new R3. And if I scroll down again, I'll just do it here. Our new equivalent system is x minus 2y minus z is equal to negative 6. And then R2 was just this up here, negative 6y plus 8z is equal to 4. And then finally our new equation 3, or R3, is 9y plus 9z is equal to 36. Great, so now we have a 0 term here and a 0 term here, right? So the next thing I want to do is I want to look at this term right here, and I want to try to get rid of this negative 6 here. If I took a negative 1/6 constant and I multiplied R2, which is equation 2, I'll get a new R2. So what I'm saying is, if we took equation 2 and we multiplied that equation by negative 1/6, then this negative 6 would cancel out, right? So negative 1/6 times negative 6y plus negative 1/6 times 8z is equal to negative 1/6 times 4. So let's scroll down again and make some more room. So this would be equal to, well, negative 1/6 times negative 6 is just y, right? And then we have negative 1/6 times 8z, which is actually going to be minus 8/6, which simplifies to 4/3, right? Z. And that's equal to negative 4/6, which is also negative 2/3. And I know we're getting fractions here, but don't be afraid of fractions. I would always keep things in fraction form as opposed to decimal form when we're working with Gaussian elimination and turning things into row echelon form, because sometimes they'll cancel out. So now our new equivalent system is going to be x minus 2y minus z is equal to negative 6, y minus 4/3, z is equal to negative 2/3, right? That's our new R2. And then 9y plus 9z is equal to 36. Cool. So my next step is I want to try to get a 0 term down here, right? So maybe if I multiply this second equation by negative 9, then I'll get a negative 9y here, and then I can cancel out with this 9y here. So what I'm saying is, if I scroll down a little bit more, I can take R3, or equation 3, and I can add to it negative 9 times R2, and that will give us our new R3. So R3 was 9y plus 9z is equal to 36. And then this term right here, negative 9 times R2, well, I'm actually going to do that off to the side. R2 was y minus 4/3 times z is equal to negative 2/3. So if I multiplied this equation by negative 9, right, it's just this equation here, I'm going to get negative 9y minus 4/3 z times negative 9 is equal to negative 2/3 times negative 9, right? So the first term is just negative 9y. And then for the second term, negative 9 divided by 3 is just negative 3. And then when we multiply it by negative 4, we're going to get a positive 12z, right? And that's equal to, well, negative 9 divided by 3 is also negative 3. And when we multiply it by negative 2, we get a positive 6. So let's jump back over here. Our R3 was this equation here, and we're adding negative 9 times R2, which is this equation here. So we have negative 9y plus 12z is equal to 6. And if we add these terms together, we get 0 here, which is what we wanted. And then 12z plus 9z is 21z. And 36 plus 6 is 42. So this is our new R3 for this system that we were working on, right? So again, I'm going to scroll down a little bit more, and we're almost there. Our new equivalent system is x minus 2y minus z is equal to negative 6. And then our new our R2 is y minus 4/3 z is equal to negative 2/3. And then finally our new R3, 21z, is equal to 42. So cool, we got a 0 term here, a 0 term here, right? We also have a 0 term here. We have a leading one here, but we don't have one here. So let's work on equation 3 and try to get the leading one term for the z term there. So if I took R3 and I multiplied it by 1 over 21, this will give us our new R3. So 21z is equal to 42, and this multiplied by 1 over 21, well, 21z over 21 is just z, and 42 over 21 is just 2. So finally, if I scroll down here, this is our new R3, right? So finally, our equivalent system of linear equations in row echelon form is x minus 2y minus z is equal to negative 6. Y minus 4 over 3z is equal to negative 2 over 3. And finally, z is equal to 2. Awesome, we have this in row echelon form. I'm actually going to stop the video here, and in the next video, we'll go ahead and use back substitution. I'll show you a graphical approach to finding the solution set, and we'll check our original system of linear equations to see if our solution set is valid.